My name is Michael DeWitt. I am a developer relations engineer on the Earth Engine team. I've been on the Earth Engine team for 10 years. 8 of those years as a software engineer building pieces of the infrastructure. So the backend, image processing stuff, ingesting new data, connecting Earth Engine to other services. I built front-end things like the code editor and Earth Engine apps. I worked on pieces of those. And now I work as a DevRel engineer relating to developers such as you all. Even if you don't think of yourselves as developers, we're going to be doing some development today. We're going to be wiring up some cloud tools for pushing data through cloud systems. So rather than the philosophical underpinning of today is we're going to be pushing data to people, pushing data through the system rather than pulling it. And that difference is just the level of activity and engagement that you as a stakeholder have with the data. You won't need to be actively looking at a dashboard. The idea is the data will come to you when certain thresholds are exceeded, certain metrics move. And so we'll be using Wildfire as an example, but really I want you to be creative and try to apply these techniques, these pipelines, these utilities to whatever your problems are, whether it's monitoring seagrass or getting information about drought in a particular area or applying a model to look at flooding before and after events and get push notifications about how roads are affected. So Wildfire is our theme, and we'll get started. To follow along, I'm going to try to have a thing that we can all follow along with. I was joking a little earlier. I deleted like all of my configuration, so we're going to try to do stuff live here. If you want to follow along, you'll need a cloud project set up, and you'll have to have a billing configuration on there. So you need some mechanism for paying, not for Earth Engine, but for the other services that we're going to use, cloud functions, BigQuery, cloud storage, etc. All right. Any questions so far? No. I'd like to also introduce my illustrious teammates. You all can introduce yourselves. We got mics over there.
My name is this on? Okay. My name is Brady Allred. I'm a cloud geographer with Google and very happy to be here and to help.
And my name is Jorge. I'm a front engineer on Earth Engine.
So as I decide to do difficult things and we're jumping back and forth across different cloud tools and services, these folks, if you have a question, you can raise your hand. If you have an issue on your laptop, we're going to try to squeeze in and juggle around. There's room. Do you want to join? You can join. It's okay. We're just getting started. So I think of this process as operationalization. Building operational workflows, that's like a really buzzwordy word that people use today to talk about systems where users don't necessarily have to intervene to get information. I think of operationalization, operational workflows like this. This is my definition. You're not going to find this anywhere outside of these slides necessarily. But just breaking this down, we all kind of know what a process is. But making it easily and robustly repeatable is really about doing it a bunch of times and having it not be something that you have to take care of. I think of this like care and feeding. You shouldn't have to actively intervene, shouldn't have to actively work with your pipelines in order for them to give you information that's actionable and useful. Okay. We're going to walk through a couple examples today of different kinds of workflows. So the first is just ingesting new data, pulling data into Earth Engine, reacting to new data appearing, in this case in a cloud storage bucket. I want to give you like Lego bricks, Lego pieces that you can think about. So if you have a process or a pipeline or people who put data into cloud storage today, this gives you a way to automatically move those data into Earth Engine and create Earth Engine assets out of those data. But you can think about this as a way to react to new data showing up in a particular place. The second is, this is a super common request. Hey, I have an Earth Engine process that I want to run every week, or every day, or every hour, or every 5 minutes. This is scheduling. So running a thing at a cadence. And then D, for the detail focused among you, you'll see that C is not on here. I'll explain that in a minute. D is monitoring a particular area. This is really our wildfire thing. We're plumbing data into BigQuery, and then doing that once. We're doing a big movement of data, and then doing it repeatedly over time so that we can have alerts, get pushed information rather than pulling it to ourselves. The friends that we make along the way. These are different cloud tools and services that we'll cover today. So these are the Lego pieces. These are the bricks. Cloud functions. So cloud functions are, I think it's a great name. They're little pieces of functionality that run independently in a serverless way, and they are just packaged up chunks of code that live for just a few minutes, typically, usually less than 5 minutes. There's not a lot of processing power in the environment in which they run, but it's really nice because it means that you don't have to think about or manage any of the infrastructure around them. It feels a little Earth Engine-y shaped because these are chunks of code that you can run, they can react to things, you can chain them together, but these will run quickly, easily, and scalably. So you can have these little chunks of code run in a reactive way. The second is Cloud Scheduler. This is just a thing that fires off events at a particular cadence, pretty straightforward. I copy-pasted these descriptions from the pages on cloud, the cloud product descriptions. We'll also be using Looker Studio, which is a dashboarding metrics business intelligence tool for getting insight into data feeds, data flows, subsetting, doing all sorts of like metrics, and I view it as like a fancier version of the spreadsheet graphing utilities that are in like Google Sheets. Some more helpful friends. So this is BigQuery. Oh, I have a clicker. Forgot about the clicker. BigQuery. Who here has used BigQuery? Like show of hands. Who here wants to use BigQuery? Come on, all of you. Come on. We are, going to talk about BigQuery. It's a rough way to think about it is that it ticks a lot of the same boxes. It has a lot of the same behaviors that Earth Engine has. It's another Google Cloud tool. It is really scalable, large data collections, does a lot of distributed processing. You don't have to think about the infrastructure. You write little chunks of code. It runs in BigQuery, and you can get results. I compare it often with it's sort of the Earth Engine of vector data, so tabular data. It does a really good job of scaling and processing, scaling the storage of and processing of large amounts of vector data. So we'll be putting some vector data into BigQuery so that we can use it. Cloud functions, just a little more detail here. They run kind of anything you want. We'll be using the Python and JavaScript just because those are what Earth Engine uses. Those are the Earth Engine client libraries. They don't persist, which is kind of the important part. So you can't like run a cloud function that saves something in the cloud function environment. It disappears. It's almost like a little container that runs, if that's a helpful metaphor. About pricing, you get 2 million invocations for free per month. I personally have never gotten anywhere near that, but you get 2 million before you start incurring any costs. Earth Engine tasks. Another show of hands. Who's like run an Earth Engine task, a batch task? Okay, not too many folks. Earth Engine tasks are a way of doing processing asynchronously in Earth Engine. So you can, rather than send a response and get a result back from that response, this is send a response and let it process in the background. This is really useful if you want to do something that takes more than the 8 seconds that you're willing to wait for a response to come back. If you have processing that requires days of computation, results that require a lot of heft, You can use Earth Engine tasks to do that. The tricky bit here is that there is no publication or subscription, no pub/sub integration. Pub/sub is another tool. Do I have a slide? Nope. Pub/sub is another tool where it's basically connecting publications and subscriptions. So there are topics in pub/sub. Tools can publish to pub/sub, and then other tools can subscribe to those publications, to those topics. And so that's a nice mechanism for passing information back and forth, and again, building like reactive systems in cloud. We'll use a bit of pub/sub. Just note that Earth Engine tasks don't have pub/sub, so we sometimes have to do a little bit of hacking and a little bit of trickery to understand if an Earth Engine task has changed status. It's just a note. Okay? I spent too much time trying to write haikus to capture each of these cases. I'm not going to read it to you, but this is about scheduling tasks. So I did this a little out of order, but scheduling tasks to run at a particular cadence. So if we have an Earth Engine export task, for example, we can choose to have that run every Monday at 9 a.m., and we're going to use Cloud Functions to actually do the execution, to manage the execution. Our function will kick off an Earth Engine task, and that whole process will be led by the Cloud Scheduler. Okay? So we're going to kick off there. This is how you get to the code. This is a GitHub repository, which looks like this. So tinyurl.com/ee-code. Hopefully you all can remember that. I'll give you another couple seconds. So this is a set of demos, a set of operationalization demos, which fire off tasks. In this case, this is example A. Sorry, that first slide was out of order. I was juggling. So this is example A. We're going to put this Python code into a Cloud function, and then we're going to organize that Cloud function. We're going to set up a scheduler so that it runs every so often. Any questions before we dive into it, jump into it? Okay, cool. Everybody here? Everybody here that wants to be here. All right, great. So Cloud functions look like, I'm just going to open Cloud functions. Give my laptop a second. Great. I have a function here. I'm going to delete this. We're going rogue here. You can navigate to Cloud functions here in the Cloud console. Let me just check time. We're going to have to go quick. Cloud functions, you just type what you want to get to. You click the Cloud function page. It brings you here. If you've never interacted with Cloud functions before, you will get a pop-up in your project saying, hey, to use Cloud functions, you need to enable these APIs. You need to enable the APIs. Once you do that, it will take a couple seconds, but you should get to a page that looks like this. Am I telling the truth? Great. We can create a Cloud function by pressing this button to create a Cloud function. I'm going to create a first generation function. There are two generations of Cloud functions. It's really what kind of machines, what kind of containers they run in is the distinction. Generation 1 is a little more restricted. It has a total lifetime of 5 minutes, so you can't do any more than 5 minutes of processing in it. It has less RAM. It has less processing power, CPU power. They also have fewer integrations across cloud. I think they might be cheaper to run. I don't know. I like to be a little conservative with machine resources, so I'm just going to call it first generation because this is going to be a thing that runs very quickly. Everybody hopefully knows a bit about Earth Engine by now, but Earth Engine's client builds descriptions of work to happen and sends it off to the Earth Engine server. So there's not a lot of processing here. You can think about all the computation we have to do is just building a little description and sending it off to Earth Engine to run. Okay. Let's call my function example A, and we'll give it a Cloud pub sub trigger. So trigger is what makes it run. You can see all of the different things here. Let me get rid of this little note. All the different things here, we'll wire up another one of these, sneak preview. But you can choose to have it, for example, be triggered by HTTP calls. So if you have a local process or another server process, this is a fantastic mechanism for wiring up these Lego pieces and getting reactivity, getting these little micro services, micro functions to run. Okay, so we're going to choose Cloud Pub Sub, and we're going to, we need a topic to subscribe to. So we'll create a new one here in this UI. You see, create a topic. I'm going to call my topic example A topic. The hardest part of my job is typing in front of people like you all. We don't need to use a schema. So a schema is imposing some structure on the publication and subscription. So you can put a little bit of data when you publish to a topic. A schema basically says these data have to be structured. Message retention is useful for logging, or if you want to go back and look at those data later. I don't particularly care about that. Encryption is just whose key do I use? Do I use a Google key, or am I providing my own through some key management service? I'm going with Google's. And I'm creating this pub sub topic. Okay. I don't need to fiddle with any of the runtime configuration, but here's where I can specify the build environment or any other sort of complexity for the container that I need. Okay, saving it, clicking next. All right, so this brings us to a page where we can configure the code that actually goes into the function. And here, this is where the code is already conveniently written. You can imagine that we developed this code in a Python notebook, or maybe if it's JavaScript, we could even write it in the Earth Engine code editor. There's a little bit of shell, a little bit of wrapper that you need, but there are examples in this GitHub repository. So I'm going to load example A. This is the Python code that I want to copy and paste into my function. You see it's a little long here, but this is going, and it's actually starting an image asset export. So this is going to check the current time. We'll walk through the code a little bit. This is all configuration, so this is handling an event. We're going to make a composite of just the last week's worth of GOES imagery. So GOES is the satellite that we're going to be using today. It's a fun satellite in that it takes an image every 15 minutes, 10 minutes. It's in a geosynchronous orbit, so it kind of sits in the same place. And it images, in this case, there are a handful of them. The one we care about is taking images of the US, in our case, the Western US. And it takes these very frequent images. If I want to do analysis of, for example, there's a product that they produce from these data that are fire pixels. So this is sneak peek. This is how we're going to be using, how we're going to be detecting where fire is and getting notified about it. So they produce per pixel every 15 minutes an indicator, a measurement of how likely it is to be fire, if it is fire, what's the area of the fire that's burning, and what's the temperature that the sensor is reading for that pixel. What we're doing here, this is a little bit of a made-up example, a contrived example, but I'm interested in, for the past week, what's like the maximum area and maximum temperature for each pixel in this stack. And so that's a lot of images. It's a new image every 10 minutes or 15 minutes. You all can do the math on that. That's 4 to 6 an hour over the course of a week. So it's a good number of images. That's a deep stack. What we're doing is just flattening this out. You can think about this as like a standard pre-processing step. If you have a data feed that's coming in and you want to condense it somehow, if you want to make your data easier to work with, easier to analyze, and you're maybe running out of Earth Engine memory, you get memory limits, memory limit exceeded errors. This is a nice way of condensing and getting flattened sort of views of your data. So that's all we're doing here. We're exporting this composite. It's looking at California, and it's exporting a particular composite for the whole state of California at full resolution so that later we can process it. There's nothing special here. We're not going to use this result in the rest of it. This is just an example of the kind of processing that you would want to do at a weekly cadence. Everybody on board? Like this is a very standard thing. So for example, when pre-processing data, it's really nice to be able to do this retroactively. So I'll show up and, oh, I have this Earth Engine app that I want to make really quick. It's taking too long to process this deep stack of data. I can go back in time, but going forward in time, I want to set up some automation so that I don't have to do this process manually. That's the inspiration here. I'm going to copy this file. We don't need to dig too deep into it. If you like, I can maybe go over this if we have time at the end. I'm trying to go quick. But we can just copy. You see this button here to copy all the code. And we'll just copy this into our function. We'll use Python 3.10, 3.11. I don't care. Does anybody have a favorite? No. So we'll call it, identify that it's Python. We'll paste our Python code in here. And then you'll see that we get a little warning, a little error message. Everybody see the error message? All right. Does anyone know what this error message means? Yes. Yeah, so our entry point here is called hello pub/sub. It doesn't know what my code can define any sort of entry point that it wants. What's the actual function that gets called when we have our pub/sub event? We have our subscription. Remember, subscription comes. We get called every time there's been a publication to this topic. What's the function that gets called? Here, we're saying hello pub/sub, but we don't actually have a function called hello pub/sub. We have a function called handle event. And so that's what will get called here. The other thing we need to provide here is the requirements.txt file, which is what should be included when we're building our example here. So fortunately, I just jumped back in the demo here. There's a file called requirements.txt. And we can copy this. And this is just saying, give me the Earth Engine API, make the Earth Engine API available so that I can build and refer to Earth Engine functions like ee.date, ee.initialize, etc. In this environment. So we're going to jump to requirements.txt and just replace it here. Okay. I'm sort of sidestepping like the process of actually writing this code. There's a really nice set of tools available for Cloud Functions that let you develop in your own environment. So again, you could use something like a notebook to iteratively work on this, test the code, run it. I'm going to assume that you all take that as homework. But this is really, we're working from code that we've already developed here. If you are starting completely from scratch, you can write this in a notebook, and then you can call it, run it, and interact with it just like it's regular code. It's just the difference is running in a notebook environment versus running here. So I'm going to deploy this. And deploying basically is building this into a package. I really hope it works. Building this into a package, packaging it up, deploying the container in a couple places so that we can then call this function later. And you'll see it spins. The reason that you wouldn't want to use this environment for doing the development is because it takes like 30 seconds or so to actually deploy the functions. So if I start running into errors and I need to debug it, I don't want to do it in this environment because there's a really long turnaround time to see if I'm doing something correctly. It's running in production. Like this, every time I turn this function on, every time I trigger this function, it's going to start another task and it's going to export more data. All right. Okay, well, I used my only time-filling joke on the main stage, so I don't have anything for you. I'm TAs. As this one runs, we can go and actually configure the Cloud Scheduler. So I'm going to open just a new tab here, console.cloud.google.com. We'll go somewhere. let's open up the scheduler. I wasn't joking. It's just tough to type. So many I's. This is the Cloud Scheduler. I got here by typing Cloud Scheduler at the top of my console page. Again, this has a real simple job. It just, on a schedule, sends out a particular publication to one of those pub subtopics. So we can start by scheduling a job. We'll give it a name. Example A scheduler. We can choose where to run it. Today, Earth Engine only runs in the US. This is a complication. It doesn't particularly matter where we run this because there's not a lot of data moving back and forth. This isn't a latency sensitive operation. But just be aware that Earth Engine is in the US. It might be helpful in some cases if you start to move a bunch of data around to be closer and have your operations hosted in the US. This runs our compositing task. The frequency is tricky. This uses an ancient language. This is a Unix cron format. You can see from the example here, ooh, it disappeared. It's a little gnarly. It's basically a method for expressing frequency in a context invariant way, I guess is the best way to say it. It's a funky language. It was built 50 years ago. But what we can do is just specify, I'm going to do a little bit of magic here. So this will run every, oops, sorry. And you all might have to bail me out. This is running every week. Actually, you know what? You're watching me struggle. Let's do a cron tool. I am not advertising any particular tools. This is the first one. Just Google searching cron tools. I want to run weekly. Let's see. It's tricky, right? It's the first field here. I'm not going to go super into it. The first field here is the minute that it runs on, then the hour, then the day of the month, then the month, and then the day of the week. So really, if we want this to run like Monday at 9 a.m., we have to specify the hour and the day of the week that we want to run on. I'm not going to be too pedantic. It doesn't really matter here. You see there's this funky slash notation. Just be aware, this is how you express cron schedules. I'm sorry, I've filed a bug. This is just a language that historically has been used for scheduling jobs. So this is pretty standard. So this we're going to do every Monday. Every Monday at 9. Here, great. Let's copy paste this. So at minute 0 of hour 9 on a Monday, this is the thing, right? Don't blame me. Time zones are tricky. Let's make this PST. Sure. Alaska Daylight Time, Pacific Daylight Time, Mountain Standard Time. This is the hardest part. We're gonna pub sub, right? So we have our example A topic. We don't need a message body, but we can say trigger function. This is just some text. This is a body. It's just something to put into that pub sub message. And this is where, if we had selected a schema, this is where we would be specifying the schema. I got to go way faster. OK. Make sure all fields are correct. I did. Great. Everybody here? We got our schedule? So this is cool. It's going to tell us that it's going to run on Monday. If you leave this configuration here, you'll get a task on Monday. We do have a mechanism, though, to run the cloud function before this. So just pausing right there, this is a thing. It's set up. It's going to give you a composite. It's going to run an Earth Engine task on Monday at 9 a.m. You are free to make that flexible. You're free to put your own code in there. This is, again, I'm giving you Lego bricks. These are tools that you can use to assemble your own pipelines. Okay? Cool. So we can manually trigger these functions. We can test these functions. I am going to run a test here. This is zoomed in. This is where I can test the function. So instead of waiting until Monday to see if it worked, we can test the function here. This is where I specify the body of my message. Remember, I'm listening for that topic, publications in that topic. We can test the function. The function is going to run. This is a helpful message. It's telling me that it's going to time out after 5 minutes. And we should be able to look at the logs. The logs take a second to populate. Again, this is not a development environment. This is a production environment. And so you can see we started this Earth Engine task here. And so this is our operation. Now this operation, so that the function invocation is done. We're finished, success. But the task that we started in Earth Engine, we kicked off a process in Earth Engine, and that can run for an arbitrary amount of time, up to 10 days. And we can get information about this task. If we have the Earth Engine command line tools installed, we can use this task ID to refer to what that task is doing, get information about it, etc. Okay? I see nods. I'm happy to see nods. Were other people able to get this to run? Yeah. Yes. Ooh, that's a hard one. This is what I used. I used 0 space 9 because it runs at the 0th minute of the 9th hour. Oh, I can make that bigger. Is that helpful? Nice. Sharp eyes. I can't see from here. Yeah, and again, I apologize for this format. I think it would be way easier to use Bard to go in and just, I want this to run every Monday at 9 a.m. We'll get there. Okay, so that's, I think that's the trickiest part of scheduling. Scheduling theoretically is very simple. It's just kicking off an event. But now we have an operational system. We are creating composites weekly. We're looking at the past week of data when we create our composites. Any questions? Questions?
Yeah, in the 500 internal server error, it said the error is that not signed up for Earth Engine or project is not registered.
Oh, yeah.
The two of us got it.
Yeah, so excellent. Yeah, the project that you're using needs to be configured to use Earth Engine. That's a great point. Glad you got that. I mean, I feel bad that you got it, but it's a good example. So these functions run in projects. So within a project, I do this execution. That project has to have all of the necessary APIs enabled. So remember in our requirements.txt, we had the Earth Engine API that we're using. We're using the Earth Engine client library. We also need to make sure that the Earth Engine API is enabled by going to the Earth Engine page. You can see all of my Earth Engine projects. So this project has the Earth Engine API enabled. If it's not enabled, you'll see a box that says enable. If it is enabled, you will also need, there's one more step here, and it's an important note. You have to register your project to use Earth Engine. This is a difference from basically every other API in Google Cloud. Most Earth Engine users don't pay to use Earth Engine. Most Earth Engine users are researchers, nonprofits doing not operational work. In order for us to keep track of that, we need you to register. So you can go to Earth Engine registration. We have docs on Earth Engine access, but the TLDR is that you have to, I'm trying to zoom, you have to register your project on this page, code.earthengine.google.com/register. And this tells us, I want to use this project with Earth Engine, and here's how I'm using it. I'm either using it commercially, or I'm using it for research. For the purposes of today's training, you can go unpaid usage and select trainer trainees. But this is saying how your project gets configured to use Earth Engine. If you are a commercial user, you would obviously, slot yourself into paid usage, and then this would use your Earth Engine subscription. You get all the benefits of having a commercial Earth Engine relationship. Cool. If that works, yes, question?
I have a question regarding the Earth Engine task ID.
Yes.
How can we check the state?
Yeah, you can use, I don't have it configured here, but you can use the Earth Engine command line tool to check the state. The identity that's running the task is a service account. So it's running under a service account. You won't see it show up in the code editor, for example. You have to use the Earth Engine CLI, the Earth Engine command line tool. But you can just pass the task ID. I think it's get task status, which will tell you how it's running. You can go in there. Usually I have that wired up, but this is a new project on a new domain. You don't care. It's just I don't have it wired up here. Yeah, and you can, so there's no pub sub for Earth Engine tasks. So what would be awesome, and if you'd like to make noise about, file a feature request, is to have integration between the Earth Engine tasks and this pub sub mechanism, so that Earth Engine tasks would publish events, and then you could react to an Earth Engine task changing status. And every time an Earth Engine task succeeds and it's labeled, it's exporting data, it's one of my data exports, I could get a notification about that. Start thinking in terms of like wiring up systems. That's where I want to get everybody today. Okay, Brady, you got.
Just a reminder, if you have a question, please raise your hand and we'll pass the microphone to you. A question for Michael. If you need help, just raise your hand and Jorge and I will come and help you.
It's going to be a tight squeeze. Okay, all right, that's example A. We're going to have to cook here. We're going to have to go real fast. Everybody ready? Everybody on board? Where they need to be? I see nods. Good to go. Okay, we're jumping back. So this is a different flavor. This is ingesting data. So new data appears. This is the example I was talking about before. Let's say I have a coworker who their job is to produce a new set of crop boundaries for a particular administrative area. And they do a new administrative area every week. And they take that data and they have a CSV file or a shape file and they put it in my cloud bucket, my cloud storage bucket. So it's just a file that appears in my bucket. What's really cool is we can use that same set of code, the same kind of logic, wiring up cloud storage to a cloud function, to Earth Engine, doing basically the same thing. This is where now we have mastery of some Lego pieces. Now we get to play with them, shuffle them around. Cloud storage speaks pub sub. So you can have a cloud function respond to a cloud storage event. This is super powerful. Somebody adds a new file. They do a new Earth Engine export to produce a file in cloud storage. Now you can wire things up in even more interesting and complicated ways. Okay, so let's jump to that one. That's example B. And this is pretty straightforward. I'm going to walk through the code here. It's a similar structure. We have one sort of higher level function, and then one function that's just a helper here. This is the function that we'll want to call to react to the pub sub event. This takes structured data from that pub sub channel. So remember, we didn't select the thing for a schema. We didn't configure a schema on our topic. Here, we're actually getting an event, and the event contains the path, the name of the file. We can parse that out, and then we can post a little log message saying, hey, I'm ingesting this file from this path. And then we just do a really straightforward Earth Engine thing of we create a new batch task, and then this is like a little manifest file, a little specification of how to ingest that file. Can folks in the back see the text here? Okay. And we just start an ingestion task. And so this is very similar. spiritually, it's doing the same stuff. So we can do the same thing. I'm going to copy this Python file. Everybody on board? We're in example B, copying this Python file. And we can go create a new cloud function. I'm going to back out, do the same process. Make a first gen function, example B. And the trigger type here, this is where it gets fun. Stuff's already wired up for us. We have to do no work here. We can choose cloud storage as the source, the triggering event. So it's using PubSub under the hood, but cloud storage, this is, I think, really nice wiring that they've already done for us. We can just say this thing runs when there's a change in cloud storage, when there's an event in cloud storage. That event type can be any of a file was deleted, a file was created, somebody updated the metadata about a file, so maybe like the permissions, or they changed the edit time. Here we're going to say creating a file, and then we'll pick a bucket. You don't necessarily, you don't have test data. You don't have like do folks have like CSVs lying around that they're really excited about? Okay, no, then I'll go quick. I have a bucket here. I have a lot of buckets. I'm going to pick Wildfire demo. I don't think there's anything in this bucket. I created all of my things. I don't need a special runtime. This is going to react to new files being created in that bucket. That's the trigger. That's going to turn on our function. The function is going to run. It's going to ingest that data. So it's going to take my CSV file and it's going to turn it into an Earth Engine feature collection. Okay? All right. Great. We're going to pick, again, Python. We're going to paste our code that we developed here. GCS to Earth Engine is the name of our entry point. And our requirements.txt, we're going to have to go again. Sorry, I have to copy this again. We're just going to copy this requirements file in here. A question we've gotten before is, how do I know which version of the Earth Engine API to use? I like to use the most recent one. So you can just say Earth Engine API and it will use the most recent one. This is just giving it a little flexibility to not necessarily have to check every time, but just use something that's more than this particular version number. Okay? Everything good? So this we can deploy this one. I'll give it a second to deploy. I happen to have a CSV file that I prepared earlier. So once this deploys, I will show that this ingests data into my Earth Engine assets. I want to keep going quickly because the most exciting example is the last one. But this is, again, just a different flavor. This is using some of the pre-built wiring in cloud. But again, my dream is that you leave this session with an idea of which pieces you can plug into another, and you have an architecture, you have processes, you can use cloud tools to make those easier, automatic, more reliable, more robust, simpler, etc. Okay. I'm going to call this one done for now. Let's move on to the last one here, the wildfires. I really want to make sure we have time to do this, and hopefully you all trust me. If I put a file in that bucket, it turns into an Earth Engine asset. You can take my word for it. If it doesn't work, talk to Brady. All right. This is my hypothesis. It's fantastic to have dashboards. At Google, we have tons and tons and tons and tons of dashboards. But we only look at them when we need to, when we know that we need to. And so alerting is super useful to get information about events that are happening and how to react to them. Really enabling us, giving us the freedom to react rather than have to be proactive and investigate and understand ahead of time. So I want to build, the goal here, we want to build a set of tools that wire together. Again, these are familiar, these are friends, we know these ones. We're going to use BigQuery and Looker Studio. Additionally, to help organize some data. But the flow, if you'll bear with me. Every few minutes, every time that this GOES satellite produces a new image, or we'll check every couple minutes to see if there is a new image. So we're looking every couple minutes. We're triggering a cloud function, and that cloud function is telling Earth Engine to look at the past 10 minutes, 15 minutes of data. If there's an image within that past 10 or 15 minutes of data, do some processing, analyze how much fire is in a particular region of interest, and for that region of interest, populate some statistics in BigQuery. So the time of your observation, and then the amount of wildfire that's being observed in our area, our ROI. Once it's in BigQuery, we'll have a big table. It's just timestamp, fire risk, timestamp, fire risk. So we'll have a big table, set of vectors. We'll put that in a tool called Looker Studio, which will let us get graphs and alerts about those data. And then that's you. At the very end. The difference between these two slides, tried to talk a little bit about the mechanism by which everything is talking to each other. These two, PubSub, normal. We've done this. These two, Earth Engine. We're using the Earth Engine client library, the Earth Engine API, to go from the cloud function. That's, we're requiring the Earth Engine API. We're pushing data into Earth Engine, making requests of Earth Engine, triggering Earth Engine exports, or even just doing calculations in Earth Engine. Dumping data into BigQuery, and then this is magic. There's just a magical connection. Looker can read directly from our BigQuery table. And then you get graphs, which you can look at, or you get alerts, notifications, emails on your phone, which tell you, hey, the wildfire risk, we saw 100 square meters burning, or 1,000 square meters burning. Maybe you have different radii that you care about differently. So within 25 kilometers, if there's fire, I treat that with a different threshold than 10 kilometers or 1 kilometer. Any questions about this? It's just wiring. Okay, we're having fun. Thank you. No, premature. We are going to go back into our operationalization demo. This is example D. Example C, I know you have questions. Example C is writing data just to a different data storage location. You're free to look at it and explore. I'm personally most excited about having data in BigQuery and then in Looker. So that's our most recent, our freshest integration. We're going to crack open this example D script here, okay? 2 notes here. This is a Gen 2 cloud function. The reason why should become apparent in a second. And then there's a bit of pre-configuration that I've done here. So this is a script. This is an Earth Engine code editor script. Whoa, not that. No, not that. There we go. Copy paste. Let's make this bigger. My goal here is to show you that you can go between the code editor, Python, cloud, exports, interactive. We're kind of using a little bit of everything here. It's intentional. It's showing that these pieces all kind of work together. We're all working in the same cloud environment. And so, yeah, nice, because there's a lot of observations. There's more than 5,000 images in this time frame. So, of course, we have a lot. I built this back in, was it July? And so a year's worth of 10-minute images is certainly over 5,000 elements. Hence why we need to reduce that. We did that example A, remember we flattened everything out? That's why. That's why you see red. Ignore the red. Cool. So what we're going to do, we're going to fiddle around. There was a fire burning in this particular area of Oregon when I last gave this demo, when I published this in July. We can look for an active fire here. So let's filter down to just today and shoot, what is today? Let's look from yesterday. to tomorrow. And this is, so I'm going to read this script to you all real quick. We have a geometry that we care about. That's this little point. And we're buffering it by 10 kilometers. You see 10 kilometers. We buffer it by 10 kilometers, so we get a little circle around it. That's our region of interest. If you have a particular region of interest that you care about, maybe it's a park boundary, maybe it's your home, maybe it's a set of different, a multi-point or multi-geometry, maybe it's a state, maybe it's a country. You're free to define that here. Just know that this is going to determine how many pixels we're looking at when we're doing the processing. Okay, so this is our little spot. We want to know where there's fire. We have this nice function called getFireStats, which turns an image into a feature. So it's a dictionary that has some information about when the image is from, and then the amount, the sum of all of the area burnt and the temperature fields. Questions? Yeah. Oh, can we turn the yellow mic on?
Doesn't really matter. It's all right. So you said for a kilometer away, but what was the resolution of the image collection we were using before?
Great question. So GOES is funky because it uses it's in a geosynchronous orbit. So the resolution is a little tricky to define because the pixels are just physically different sizes. They get bigger as you get further away on the disk. This is, I'm going to show some pixels in a second. So we'll get a sense, but I think it's a little tough to define.
Thank you.
Yeah.
Is the code in the GitHub?
Yeah, so I got to this, sorry, I did that quickly. The question was, is the code in GitHub? This is the pre-configuration. So this is a code editor script that I linked to from my Cloud function just so I wouldn't forget where it is. But we're going through and we're updating it. So there's no fingers crossed, there's no fire burning here today. So we're going to look for an area which has some information. What we're doing with this script is we're backfilling. So this is pre-configuration. So I'm just going to put a bunch of data into BigQuery so that we have something to look at now, so that we get a graph, and it's like our function has been running for a while. So just so we have some information so we can look at a curve and get some information out. Okay, what I'm going to do here is I'm going to change fire stats here. I'm going to move this variable down. So I'm going to create a fire stats, and I'm going to call this fire images. So why did I do that? Here we were turning all of the GOES images. We were filtering them down. We were selecting the bands that we care about, and then we were printing out the statistics. Instead of just going straight to the statistics, I want to actually see some pixels. And so I'm intercepting this. I'm getting some images out, and I will create a layer in the map. So I'll map, add layer, fire images. This is an image collection, so I'll say max and just get the maximum values out. And I'll run this. And you'll see I'm inspiring you, hopefully. We're using the code editor, and we're using Python, and we're using a completely different execution environment. So it's running. It's doing a bunch of compositing. In a moment, we'll start to see some pixels come in. I swear there were fires burning yesterday. Maybe let's expand this time range out a bit. Let's also not go to 2024. So we're printing our feature collection here. You can see, depending on the number, we have 800 different images over this time frame. All right. Does anyone see fires? My favorite thing is if there are actually no fires burning right now. I've never given this presentation and there's not fires in Oregon, for what it's worth, sadly. Okay. Oh yeah, here's one. Okay, sorry. We'll give this a second to populate. I'm gonna just hit run again real quick. The point is that we're gonna find an area. We're gonna pretend that has a fire. We're gonna pretend that's the area we cared about the whole time. We're gonna move our region of interest to B to intersect that area. And then we'll backfill all the data, so we'll get at least like a nice graph of how that's evolved over time. Okay. It looks like our compositing is working. I'm going to choose this pixel if no other exciting pixels jump in. Any questions so far? No, we're all rolling. Okay. So you see I'm in the code editor. I have these fantastic drawing tools. I can move the point around. I have this interactivity. And so I will get a task that I can export. So you see this task lights up. So I mapped my images. I turn them into statistics. So for each image, I run this getFireStats function. And then I export to BigQuery. And this is like, depending on how you count it, this is tens of lines of code. It's really like 7 or 8 functions that are actually being called here. Cool. OK. We're going to run this task. I'm going to run my export BigQuery task, export fire stats, and we'll call this, we're going to run an export to BigQuery. If you've never used BigQuery before, you will need to create a BigQuery dataset. So this is my project, MDWit Unix. I have a dataset in here called EE-export. Datasets can contain multiple tables. I already have a fire stats table, so I'm going to delete it. If you don't have a data set within your project, you need to create one here. And it's just, I can show you what it looks like. Nope, not that view. You select your project, and you hit create data set, demo. Great. And again, we can choose where this is hosted and the hosting status of it. We can have it wipe out automatically if we want, expiring the rows. This is BigQuery. It's a whole other set of tools. Like I said, this is sort of like a sister project to Earth Engine. There's a lot of processing power and capability in BigQuery. Let's create our data set. I'm probably still going to use my EE-export set just because stuff's already wired up there. You should also call yours EE-export. Okay. Yeah, I just went here, MDWit. So this is my project that I'm using BigQuery with. You see I selected it here. This is a play on Unix, like the operating system. It's not me. Well, MDWit is me. And just on this little 3-dot menu here, you can create dataset. So this is creating a dataset within my project. Okay. So back in the code editor, I have my export, and then, so this is the data set, and then this is the exact table within that data set. So the hierarchy is project, data set, table. Project can have many data sets, data set can have many tables. Question?
Is that table already created, or is it going to create it on the fly right here when you?
The table doesn't exist. So the table, you'll get an error complaining. So you see EE-export here just has something called flooded areas, separate demo, also exciting. But it will create it on the fly when the table doesn't exist. The data set defines things like, again, the retention policy, where it lives, et cetera. The tables are just a mechanism for organizing your data. Okay? So I am going to run this export. It shouldn't take very long at all. You'll see my my little fire pixel in here. So I know I'll expect to have some amount of data between the 9th and the 12th. And as we're waiting for that, I can also try to figure out, no, it'll go quickly. You can look and you can filter this data set down and figure out exactly when the most recent image was taken. It's either going to be it finished. It's either going to be the first or last element in this collection, probably the last. So if we zoom way down here, It's telling us that this was taken. Ooh, this is a complicated thing. This is the time of most recent acquisition. Unfortunately, it's in universal time, so this is, we're just going to say 36. We're going to say 10 minutes ago. So there was an image acquired roughly 10 minutes ago. This is 9 hours off, 8 hours off. Time is hard. Okay, so we will have, I'm going to refresh this page. We should expect to see our data in our table. Cool. We have fire stats. So this is just a one-time export, right? This is just, we're backfilling data. Question. Can we get a microphone, or you want to shout? Yes. Oh, we need a microphone.
When you linked the export from Google Earth Engine, when you link the result from Google Earth Engine to the BigQuery dataset.
Yeah. So when I ran this, it created a task. So this BigQuery operation, and I actually told it what table I wanted to create.
Yeah. Okay. So you added that in the.
Exactly. Yep. And so that's auto-populated there, or I wrote it here, therefore it's populated in the task. But I'm free to change this to a different project, a different table, a different data set, et cetera. So we're just backfilling data. Setting this up to run at a cadence is exactly the same thing that we did before. I'm going to do that in a second. We've already had the experience of setting up a thing to run on Cloud Scheduler, so I want to make sure we at least get to talk about the other stuff and make time for questions. But this backfilled data, I'm going to show working with the backfilled data. If you have it auto-populating every few minutes, it's the same spiritually. It looks the same. You're just getting fresher data over time. Okay? Sorry, you want to take a picture? You're good. All right. Super. There is, in this UI, we can look, we can preview the rows, we can see that there's information, there's no fire, and then, ooh, this is like really bad. It's a sensor in space, so you're gonna get a little jitter. There will be some noise and some differences, as even like, as the sun goes up and comes down, the camera is staying in the same place. So we'll get potentially different measurements, but I believe that there's fire in this location. We can click this little three-dot menu. BigQuery loves hiding stuff in three-dot menus. I didn't build it. But here, so remember, this is the one to create a data set. This one lets us export our data, and here we can explore it with Looker Studio, which, if you remember, that was the tool that we pointed to earlier. Looker Studio is a business intelligence tool. There's no reason that it has to be used just for business. If we're able to use it at all, perfect. It auto-populates a thing. It auto-populates a graph based on our BigQuery table that it thinks is useful. We can build, so this is a super flexible environment. I think it's really cool because I can make a bunch of different graphs fed by a bunch of different data sources, from Google Sheets to BigQuery to you name it. There are many different sources that feed into this, and I can create a single dashboard that has my fire risk for my home, my business, or Park A, Park B, Park C, or my physical assets if I'm a business owner or I'm an insurance company and I'm insuring a whole bunch of assets. What's the fire risk for different regions? Sky's the limit. But we do have to transform this to make it useful. So here, I'm gonna just change the title because I'm pedantic. It auto-populated these charts. These are a lot like if you use Google Sheets. These are the charts that you can insert in Google Sheets. But here we're powering them with this live connection to an underlying BigQuery data set, which we know how to update automatically. Okay, I'm gonna delete these. And we'll start from scratch here. I'm going to, oh, you can't see that. It's way too small. I'm going to add a chart. This is a time series chart. And I can literally just draw a box and get a time series. Does that look right? You shouldn't be satisfied with this. This is very, very not granular. So by default, and this is like a really funky thing. By default, it just breaks it down by day. So if we wanted, we could like get a bar chart, break it down by day. This is the fire in that particular region, what the sensor saw per image, but it's compositing it at a granularity that's a little too coarse. What we can do is we can click this little hidden pencil here next to dimension. And so we're changing the time dimension, changing how it's interpreted. Here it's interpreted as a date, which literally just means the day, like the whole 24-hour period. If we change that to date, hour, minute, we can get a minute breakdown. Ooh, wow. We can get a minute breakdown. This is the record count. This is how many observations we're getting. It goes from 0 to 1. What we want is the fire. So we can change this to be the area that's being burnt, the sum area. And man, I picked really badly. It had 1 pixel of fire, 1 fire event. So you can see there's that very thin slice where the area was very high. We can do it again, but you gotta believe me. We're working on live data here, people. We're looking at fire from space. So if I had done this correctly, I deleted my tables. I wanted it to be real. We could have a graph here, and you'll see typically, well, if you squint, you can probably see that each of these observations, there's a little dot here at 0. This is super fine. Oops. But this is actually all of our observations here are 0, 0, 0, 0, 0, 0. And these are the times of our observations. So that's setting up a dashboard. This is a dashboard that you can look at if we do the wiring up, and we only have 5 minutes. If we wire it up, give me 1 second. If we wire up populating new data into this table, which is in this function, you just do the same thing. Copy and paste this into a function. It will write a single row to BigQuery, so it'll look at our area of interest and just populate a new row for that image for the area that we care about. If I do that, it will just automatically update this dashboard. What's even cooler, in my opinion, is the ability to save and share here. So yes, there are other folks who are looking at this. This is just my cloud project configuration. If I hit view here, okay, we have 2 slightly different observations. Fantastic. I'm glad they got the fire under control. We have our 2 observations here. What I can do in this view, so I'm viewing it right now. I can have other graphs, other dashboards, other tables here. I can click this little bell, this little hidden bell that only shows up when I mouse over it. This, I think, is the best feature of Looker. There are lots of tools that will make a graph of data, but Looker lets me configure alerts. And so I can configure this alert by clicking on that bell. Just to do it again in case you blinked, here's the bell. Click it for alerts. I can say fire to extreme, if I can spell. Describe what it is, and then set metrics. So I can say the area is greater than, and say 400,000 square meters. And the time of day is such and such, and the temperature is higher than a given threshold. I can configure all of these alerts that will send me an email, will push a notification to my phone when this alert threshold is crossed. So I can configure that, and it's that easy. I can set up multiple alerts. You can see here's one alert. I can set up others. It's not just fire. It's anything that you can measure repeatedly and plumb through using cloud tools. So again, continuing, I want to give you all pieces that you can plumb together and be able to express really sophisticated things. If I had a TensorFlow model, I don't know if folks went to the neural network session or classification session. If I have a TensorFlow model that I can apply to sentinel images that are coming in every few days, and I can detect that there is an increase or decrease in sea ice coverage in an area that I care about. I can populate a database, I can get an alert, I can get a chart, I can make everything happen in an automated way so that I am informed without having to pull information. We have a couple minutes left for questions. I see 2 here. Can we pass the mics?
How do you trigger the looker from the BigQuery?
Yeah, the question is, how do you trigger looker from BigQuery? So getting from BigQuery, so BigQuery operates, the unit here is the table. I can click this little 3-dot menu, export and explore with Looker Studio. And Looker Studio, if you remember my slide here, BigQuery to Looker there's this little like magic sparkles. That's it. It's the 3-dot menu. The table will be updated live, and as the table is updated, our Looker Studio dashboard is updated. We can also do kind of sophisticated things like, if I jump back here, I'm done with the alert. Oops, getting the report shared. It's not, no, I made it. I can also do things like in here add a, oops, hit reset. I'm not going to fight with it. I can add information about, it's jumping around. I'm sorry. I can go in and I can add controls. So I can have, for example, sliders, checkboxes, filters. There's a really nice date range control. So I can literally just draw that in and then have control over what dates are displayed in my chart. I can have this chart. I can share it with other contributors on my projects, etc.
So is that consider dynamic application? Could be used as a dynamic application?
It's totally dynamic. As you update and make changes to the table, it's immediately reflected in Looker.
So you could embed the URL to a website or somewhere?
Totally, yeah. You can share it with other people. Yep. There's a question behind you. Yep.
Is it also possible to integrate a map in this? So that, like, when you see this updated, you also see the map updated?
Allegedly. I haven't figured out how to do it in a nice way. I haven't spent too much time on that, but it is, I believe, possible. If it's not possible, I'd make noise at the Looker team. Once you start getting into maps, and I'm biased. I'm declaring my bias here. Once you start wanting to see a map with live information behind it, I think you usually want to use an Earth Engine JavaScript application or maybe a code editor link, because with a map, especially with like GIS data, I want to have the tools to like click and inspect and go in and get more information about context, use other geospatial data sets. And I'll be honest, I don't expect Looker to have like really deep GIS support anytime in the near future. Yes.
Just to let you know, I've been using the map, and if you give latitude, longitude, but it's not as good as the other features, the map features from Google Earth, but it works at least.
It does. You can also, Keiko, thanks. Yeah, you can use BigQuery GeoViz to actually look at your BigQuery data. So if we jump out, you can, oh no, it's BigQuery GeoViz. Yeah, I can never remember the URL. BigQuery GeoViz. This is a tool which lets us pull in BigQuery data, geospatial BigQuery data. Unfortunately, the table that we created doesn't have any geospatial information. We didn't say, this is the area where the fire is worst, or this is the pixel. We just said, here's the time, here's the total intensity. But there are other demos, and that's a good chance for me to plug if you, oh, question, yes, real quick.
The button where you initiate the alert from Looker?
Yeah, the little magic bell. Let me see. You have to publish the table, click view, and if you hover over it, you get a little bell with a plus. So I'm going to save and share here. Yep. If you view it, you get this, you hover and it disappears. You see this bell? Again, a little bit of mysticism. Check out the BigQuery integration demo. There's more tools, more features to plumb data into BigQuery. We have a new Qwiklab. I'll be sharing links to that in the next session about getting data in and out of Earth Engine. This is the URL, Google EEBQ Qwiklab. I can't zoom in on that. But this is a lab designed to walk you through integration with BigQuery. This demo looks for flooded roads using Sentinel imagery. Also doing kind of fancy wiring with the rest of cloud. We're at time. You all have been great. I appreciate your patience here. We're all working on this together. Thanks.